Another useful observation about, or fact rather, or about or relating to cyclic quadrilaterals is that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. What does that mean? I'll just give you a cyclic quadrilateral. Now, the interior angles are the one I'm going to draw in white. A, B, C, D. These are the interior angles. Exterior angles are adjacent to the interior angle. So if I extend this line, the angle here is an exterior angle. It's adjacent to this interior angle B. And the rule is saying that this exterior angle, which I'm going to call E, let's call it E1, is equal to the interior opposite angle. How do you work out the interior opposite angle? Well, this E1 is an exterior angle. Its adjacent interior angle is B. The opposite angle to B is D. So the interior opposite angle to E1 is the opposite angle to the interior angle adjacent to E. I'll take that again in a simpler fashion. If you have an exterior angle and you want to determine the interior opposite angle, just first find out the adjacent interior angle, which is B here, and then find the interior angle that is opposite to that angle, which is D in this case. So what we know now is E1 is equal to D from this statement here. And why would you believe that? Well, let's think about it. We have a cyclic quadrilateral inscribed within the circle, as you can see, and its interior angles are A, B, C, and D. And you know that the opposite angles of a cyclic quadrilateral are supplementary. So you know that B plus D is equal to 180 degrees. You know that for a fact. You also know that angles on a straight line add up to 180 degrees. B and E1 are angles on a straight line. So B plus E1 is 180 degrees. So B is obviously B. And because B plus D is 180 degrees, B plus E1 being 180 degrees means that D is equal to E1, or E1 is equal to D, which is what this says. Here's another example. So the interior angle here is A. The exterior angle I'm going to call E2. What's the interior opposite angle to E2? Well, let's find the adjacent interior angle and then the interior angle opposite to that interior angle, which is C here. So from this, you know that E2 is equal to C, and the proof is pretty much the same. A plus C is 180 degrees because A and C are interior. They are opposite angles of a cyclic quadrilateral, so they're supplementary. A and E2 are angles on a straight line, so they are also supplementary. They add up to 180 degrees. So you know that C is equal to E2, or E2 is equal to C. In case you haven't noticed, some of you might not have, we have A here, and we have 180 degrees. A plus C is 180 degrees, so A plus E2 is 180 degrees, so C must be equal to E2. That's all.